Appendix, automating your applications with make files. In this appendix, compiling and linking your applications, automating your work, applying work with inference rules in your make files, getting the most out of make files. Since the beginning of time, or at least since the beginning of the Unix operating system, programmers have used a utility called make to build their applications, and it's still often used today. The make utility looks at which of your source code files have changed and decides what needs to be compiled and built. Development tools such as codes, colon, blocks, and Microsoft Visual C++ don't require you to use a make utility because they have such decision-making features built in, but many free compilers use them. Fortunately, the process for creating and using make files is no longer as difficult as it once was. Third-party libraries come with the make utilities, such as the Boost libraries Boost.build, see Book 6, Chapter 4, that greatly reduce the complexity of creating and using make files. Before using make, understanding the compile and link processes is important. In this appendix, we cover the compile and link processes and advise how to use make to automate your building. Please note, however, that make itself is a complex tool and enough information is available about it to fill an entire For Dummies book. Therefore, we suggest that you don't worry about mastering make and what are called make files. Instead, read the appendix, this appendix, so that you understand them. Then, if you work with make files in your projects, start with an existing one. If you understand it, you can easily modify it for your project. Compiling and linking. When you create an application, you write your code in various source code files. For one application, you can have many different source code files. Some large corporate projects may have hundreds or even thousands of source code files, with dozens of programmers working on the different files. As you can imagine, dozens of strong-willed programmers working together makes for quite an adventure. But by using tools like make, these programmers are able to easily work together without a single disagreement ever taking place. Okay, we lied. But nevertheless, make makes their lives easier. To transform these source code files into a single application, you need to compile and link them. Compiling means transforming your C++ code, or whatever language you are using, into a machine-readable language called assembler. The assembler language differs among types of processors. Most of you reading this book are working on some version of an AMD or Intel processor, so the C++ compilers you use normally translate your applications into assembler code, also called machine code, that's appropriate for the processor on your system. You can also tell the compiler to target some other processor in many cases. The compiler stuffs all this assembler code into a file called an object file, and typically names the file the same as the original source code file, but with an .obj or .o extension. For each source code file, the compiler makes a single object file. After you have compiled all your source code files, you run the linker. The linker takes the object files and combines them into a single file that you can run on your computer. This single file usually gets an .exe extension, which stands for executable. The origin of this term comes from execution, which refers to the running of an application and probably has something to do with what the user of the first computer application wanted to do to the programmer after using the application, but we're only guessing. The linker can produce other kinds of output files. For example, you can create a .lib library or .dll dynamic link library or DLL file. These files contain executable code just as the .exe file does, but you don't execute them as standalone files. An .exe file normally loads them and uses the executable code they contain. The compiler also inserts into the object files a great deal of information in addition to the assembler code. For example, when you are still in the process of developing your application, you can instruct the compiler to put debug information in the file. Although sometimes the debug information goes in a separate file, it depends on the compiler. Debug information includes the names of your variables and the line numbers of the source code. When you use a debugger tool, that tool knows about your code by looking at the debug information. The compiler also puts information about the code, such as the names of the items that occur in other source code files. For example, if you're writing code that calls code in another source code file, the compiler includes the name of that code in the object file. That way, the linker can connect the two. Technical stuff. Understanding external linkage. As an example of where you may encounter external linkage is when code in one source code file calls a function in another source code file. When the compiler compiles the first source code file, it doesn't know where in the compiled assembler code the routine will be when it compiles the second source code file. And even if the second source code file is already compiled, the compiler isn't particularly interested in digging around the other object file to figure out where it is. So instead, the compiler simply creates a reference to the routine. It places this reference inside the first object file. Later, the linker replaces the reference with the address of the call, and that address is what will end up in the final executable. This address, however, is just temporary and serves as a placeholder until the final application is loaded into memory. When you run the executable and the application gets loaded into memory, a special application called the loader replaces the address with the actual memory address where the routine is located. Phew. Your code may also call code that lives outside your application, such as a routine in a DLL. In that case, the compiler still puts the name of the routine inside the object file, but at link time. The linker includes a placeholder that notes the name of the item or perhaps a unique number and the name of the DLL file. The linker puts that information inside the executable file. When you run the executable file and the application gets loaded into memory, the computer first makes sure that the DLL is loaded, following the same steps here that it's using to load with the executable. Oh my. And then replaces the information with the real live address of the DLL's routine again. Phew. Finally, compiler can add resources to the object files such as graphics and sounds that your application requires. These resources appear as data that the application accesses later. Data appears in separate areas from executable code within the file, but you don't need to worry about the object file organization. The compiler takes care of managing both code and data for you, automating your work. When you're developing an application working with, say, 10 different source code files, and you're ready to compile and link your work, you can compile each source code file separately and then link them all together. However, it would be nice if you had to compile only the source files that have changed since the last time you compiled. After all, if one of the source code files was compiled to an object file earlier and hasn't changed since the last compile, Why bother compiling it again? The solution is to use some kind of special application that checks to find out which source files have changed and compiles only those. Or if none of the source files has changed, the special application checks only to see whether any external libraries have changed and, if necessary, does only a link. Or if nothing has changed at all, do nothing and call the application up to date. That is exactly what the make utility does. Using make, you can be sure that only the object files and executables that are out of date get updated. How does make do this? It simply compares the dates on the files, that's all. It looks at a source code file and its associated object file. If no object file is associated with the source code, it definitely compiles the source code files. If an object file is available and the object file is newer than the source code file, make knows that the source code file hasn't changed since the last compile, and therefore there's no reason to recompile it. But if the source code file is newer than the object file, it must have changed since the last compile, and thus the make utility compiles it. To build your application by using make, you just type this at the console, that is either the terminal on Mac or Linux computers or the command prompt on Windows computers. So all you do is type the word make. Remember, the different make applications have different names. For example, Microsoft provides the and make. Utility that you can read about at http://msdn.microsoft.com/library/dd ny37ha.aspx. When using these other kinds of make utilities, simply type its name instead of make. If anything in your project needs building, make will do it. Otherwise, it prints the simple but sweet little message, make my program is up to date. Well, this is all fun and dandy, except for one little catch. The make utility needs something called a make file, capital M, but everything else is lowercase. The make file lists information about what exactly it's supposed to make. Unfortunately, make files aren't exactly simple. The make utility and its make file concept was, after all, invented something like 30 years ago, back in the dark ages when computers were made of stone and cars had square wheels. But that's okay. Today's computers still handle make files, and you can find out how to use them. The next section covers what exactly goes inside these animals. The things in the files are themselves interesting little animals called inference rules. Implying with inference rules. Everybody loves rules, and so does the make utility. Before make knows what to make, you need to supply it with a set of rules. Programmers have decided to call these rules inference rules, for lack of a better term. Well, actually, tons of better terms that take up less space are available, but they chose inference because the make utility will infer what it's supposed to do based on the rules implied by the make file. In general, the inference rule specifies the file you want to create, such as an object file, and the file or files it depends on, such as its associated source code file. Next, the rule states how exactly to create that file. For example, if you have an object file that depends on a source code file and want to create it, for example, if you have an object file that depends on a source code file, the way to create it is by running the compiler command. A typical inference rule looks like this. The first line specifies the names of the file you want to create. then it has a colon, and then the files it depends on are listed. The next line starts with a tab and then lists the commands to run to create that new file, with one command per line. The following example is a rule for creating a text file. I was done with the chapter. I am. This is the appendix. Test.out, test.txt, cp, test.txt, test.out, echo worked, test.out. But I have a question since you're here, Renardina. I'm considering, okay, were you trolling me when you said I should go back to the start and read the pages that I didn't read already? Was that a troll? Bernardina, did you peace out? Okay. I hope I get an answer from you. The first line means that we want to create a file called test.out, and it depends on the file called test.txt. If test.txt is newer than test.out, meaning it has changed since the last time this rule was run. I read everything from the start. However, I didn't start, I just went back to look at my first live, and I didn't stream any of it until page 288. So I'm trying to figure out, would it make sense to, after I finish the appendix today, if I can check this book out again, which I'm going to go see about as soon as I finish this appendix, would it make sense to then go back and read everything up through page 288? Because although I did read it, I didn't read it on stream. Technical stuff. You may notice something interesting about the breezing inference rule. Instead of using the usual copy command, here we used the cp command, which is the equivalent under Unix. Many of the free make utilities on the market, such as Cygwin, spelled C-Y-G-W-I-N, rely on Unix style commands. If you prefer to work with the MGW compiler or the Borland compiler, you can use the copy command instead. I'm telling you, I literally that this here is the very first live that I did for C++ All-In for Dummies. And I spent the first half hour just rambling. It's 2 hours and 1 minute run time, and I spent basically like 2/3 of the time rambling. But as far as the book goes, I started off at this is where I started for streaming, which is at the tail end of page 288. So would it make sense to, before I actually turn the book in, read everything up to that spot, so that way I have it on record, because I'm thinking of doing that. But additionally, I'm going to be doing some coding though. So like this will be like less of a priority, since technically I'm done once I finish this appendix. I swear I read this before, but I don't remember if I did it on stream or not. The appendix. To start coding. Okay. I'm just saying, because you're the one who brought up starting from the start of the book. And I'm like, was that a troll? So I guess I was a troll. Alright, I'll just finish this appendix, because I only have another, like, 8 pages left. And I can start some coding. I gotta return this to the library. I was just getting the appendix read before I moved on. Plus, I need the reminder about how my files work. Tip, if you want to try out the Makefile business, create a text file called Makefile and put the following in it. I'm not going to put the book in the trash. It's called library book. I have to return it to the library. Test that out. Test that. Text CP. Test that. Text. Test that out. Echo. Word. But okay. So I was looking at it. And I think what I want to do is set up on my boyfriend's old computer. I want to set up a Linux server, and I'm kind of leaning toward either Ubuntu server or Ubuntu Pro, because technically the Pro should be free, because I'm just a personal user. And then setting that up with Apache to help with whatever web stuff I might want to do later. I'm not planning on doing anything like crazy. It's more so like getting some experience. Note that the second and third lines begin with a single tab, and then that way I could use Linux Mint on my computer, and I could communicate with my boyfriend's old computer via Linux, and then I could use that to help with like file server and web server and whatever server. Note that the second and third lines begin with a single tab. Do not start the first line with any tabs. Next, make a text file in the same directory and call the file test.txt. Finally, while in the same directory, type the following command: make. So the quickest way for me to start coding would be just get the Linux Mint and just start off just with that and don't worry about the server part. That would probably be the start. Note that you will want to have a make command installed. For example, you can obtain Cygwin at http://www.cygwin.com, all lowercase, /book. 6 chapter 4 describes the boost.build compiler. You can also obtain the Borland compiler from http://www.embarcadero, spelled EMBARCADERO, all lowercase, .com /downloads. Tip: if you do some exploring, you are likely to discover that you can optionally name your makefile something other than makefile, and then specify your file name in the make command. For most versions of make, you do this by typing make-f file name. However, we do not recommend doing this. Most programmers always use the name makefile, and if you call yours something different, you are likely to rattle their chains a little. Computer people are not known for their flexibility, and if you do this, your coworkers probably won't pay for your pizza this Friday. Using rules that depend on other rules. Some special situations arise when working with inference rules. For example, test.out may not exist at all. In that case, the commands will definitely run because the idea is that this rule tells how to create a test.out file. Another special situation deals with test.txt itself in the previous examples. Does it depend on anything? For example, another rule may say this. Test.txt, original file.txt, cp original file.txt, test.txt. The rule states that test.txt depends on the original file.txt. If original file.txt has changed, make creates test.txt based on the command, which is a cp command. As it turns out, make is surprisingly smart for such an old computer tool. Before it ventures into the rule to create the test.txt, it sees that test.txt depends on original file.txt and checks to see whether original file.txt has any rules. If so, make keeps tracing backward until it gets to a rule with no prior dependencies. So these two rules would all be lumped together into a single make file. Test.out, test.txt, cp test.txt, test.out, echo worked test.out, test.txt, original file.txt, cp original file.txt, test.txt. Tip. You can have multiple rules in your make file, and they don't have to depend on each other. If you have multiple rules without such interdependencies in your file, however, make starts by running the first rule that it encounters, making specific items. When you have a make file filled with all sorts of rules, you may want to build only one particular item inside it. For example, if you have dozens of source code files, you may want to just compile the source code file you're working on, without building the whole shebang all the way to the final executable. To specify exactly what you want to build, just throw in the name of the item after the word make. Make test.txt. If you're working with the make file with rules for both test.out and test.txt, then when you issue this command, you create only test.txt. You will not create test.out. However, it may if make requires other rules to be built before, hi Nicole, before this rule can run, it will run those rules. So with the example we give regarding multiple source code files, if you want to compile only the one called niftyfeature.cpp, you will type make niftyfeature.o. Remember, a note that the file extension in this line is .o. The reason is that although you're compiling the source file niftyfeature.cpp, you're making the object file niftyfeature.o. Therefore, you specify the name of the object file in the make command when you want to compile a particular source file. How are you doing, Nicole? Hopefully you had a great weekend. Depending on multiple files, not only can you have multiple rules in your make files, but you can have one rule that depends on multiple files. This is common when building files, particularly in the link step. For example, the final application itself, such as myprogram.exe, is going to depend on many files, including all the object files in your project, as well as any libraries. To list multiple dependencies, you create your make file rule. Nicole says, I'm doing okay, my weekend was good. I didn't do much. Oh, that's the best kind of weekend. Just some chill weekend. Those are fun. Mine was alright. I had a little something to do yesterday, but nothing too crazy. To list multiple dependencies, and then Saturday was just pretty much chill time. To list multiple dependencies, aside from my usual Saturday stuff. To list multiple dependencies, you create your make file rule. listing all the dependencies on the right of the colon. Separate with spaces, as in the following example. Don't use commas or semicolons to separate them. I'm doing all right. Thanks for asking, Nicole. Just closing out this book. Test.out, test1.txt, test2.txt, echo, hello, test out. Here, test.out depends on both test1.txt and test2.txt. When you run make, if either of these two latter files has changed since the last time you ran make, the echo line executes tip. If you have lots of files to the right of the colon, you can put them on multiple lines if you prefer, by ending each line except the final one with a backslash. As in the following example, test.out, test.1.txt backslash test.2.txt, echo hello, test.out. Often people indent the following lines with a single space, as we did here, primarily for readability. Although using a tab here is okay, we don't recommend doing that. The tabbed line makes it hard for us mere humans to read, because the tabbed line will be aligned with the commands that follow. Tip: if a header file changes and your source code file uses it, you will want your source code file to be rebuilt the next time you run make. Therefore, including header files in your list of dependencies is a good idea, but it can be difficult to figure out what header files your source file depends on. It turns out that there's a nifty little trick that can help you do this. Compilers such as Cygwin and MinGW can build such a list for you. To do this, you can use the -M option, as in the following example. G++ -M main.cpp. When we ran this on whatever source code files, we saw the following appear on the screen. That's what was shown on the screen. Just pausing so you guys who are interested could look at that. I don't feel like reading all that. Notice 2. The left of the colon is the object file main.o. To the right are the files it depends on, starting with our source code file main.cpp. The several header files follow, including their paths. To use these, you would then paste them into your make file. They represent the first line of the rule. Tip: if you want to use the -M option to generate your dependencies, but only want to list the header files in your project and not all those other bizarre ones that live inside the main include directory, you can throw an extra M. So that looks like this. G++ -mm main.cpp. When we run this, we see only the header files in our project. Here's the output we get, which is main.o, main.cpp, main.h. Often this is more useful because it's rare that the system header files change. Compiling and linking with make. To really use make in your projects, you need rules that tell make to run the compiler. For each of your source code files, you want to build an object file, and from there you want to link the object files into a single executable. You can write a make file that specifies these rules, such as the following. My stuff.o, my stuff.cpp, G++ dash lowercase c, my stuff.cpp dash o, my stuff.o. The first line says that our object file depends on the source file. The second line is a command to run to create the object file. Linking is a bit more complex because to successfully link an application, you need to include several libraries. Which libraries you include depends on which compiler you use. The beauty of using Makefile, however, is that after the information for compiling and linking is there, you don't need to do anything else. When it's time to build your application, you simply type make. Remember, certainly you'll be compiling and linking. Remember that with Makefiles, the best way to use them is to simply understand them. That way, you can take an existing one and fix them up so that they work with your particular project. Writing one from scratch requires a strong knowledge of the intricate workings of the inference rules. Toward the end of this appendix, in the sidebar, discovering more about Make, we will tell you where you can find that information if you really want to study it. Cleaning up and making it all. When you have a Makefile and a huge project, you may want to periodically start fresh, cleaning out all your object files and the final executable before you do a build. For example, you may be working on a project and so much has changed that you would prefer to start fresh with your next build. To do this, you can include a clean section in your Makefile that looks like this if you're using Cygwin. Clean. Remove dash F asterisk or star dot O, remove dash F star dot obj, remove dash F my program.exe. Note that no files are listed after the colon, thus when you type make clean, the rm commands which delete the files will always run. Tip: if you're using either MinGW or Berlin compiler, you want your clean section to look like this. Clean, delete, star.o, obj, myprogram.exe. See macros. Environment variables can include macros. A macro is basically a word that represents something else that's probably more complicated. For example, you may have something like this. My files equals 1.cpp, 2.cpp, 3.cpp, 4.cpp. Then any place in your Makefile where you want to refer to the four files, 1.cpp, 2.cpp, 3.cpp, and 4.cpp, you can instead simply write $, opening parentheses, my files, all capital letters, and closing parentheses. When you access a macro, you precede it with the $, and you put the name inside parentheses. The make utility then knows that this is a macro and needs to be expanded. All right, last page of the appendix. And it looks like this is just going to be it for my reading of C All for Dummies. Technical stuff, discovering more about Make. If you want to be serious, and be a serious diehard, late into the night, big time maker, you can read this online manual. You can do tons and tons of things with Make, and you could easily stay up all night playing with it all, or at least trying to learn it all. You may not ever have a need for all the things you learn, but you never know. Here's the site. And http://www.gnu.org/manual/ Scroll down to find entry on Make. Make will be followed by a hyphen and some numbers representing the version number. When you click it, you will see an enormous page filled with the winners of Make. Trust us, it's long and boring. All right, last section. Getting the most out of Makefiles, here are some other features you can use when working with Makefiles. If your lines run long and you want to continue them with the next line without confusing poor old Make, you can end a line with a backslash and then continue it on the next line. Your best bet when working with Makefiles is to start with one that you know works and then change it so that it applies to your current project. The truth is, almost no programmer creates a Makefile from scratch. Programmers don't like to work that hard on auxiliary projects, like messing with Makefiles. They'd rather get to the programming. So if you need a starting point, you can find a sample in this appendix. Most Makefiles will have a rule called all. The idea behind this rule is that it encompasses all the other rules. When you make all, you can build your whole project. You can include comments in your Makefiles by starting them with a hashtag character. These comments are not used by the Makefile. Makefiles can include what are called implicit rules, which are rules that pertain to a whole set of files with the same file extension, such as .cpp. These comments can help you understand the Makefiles when working with them. If you don't like Makefiles, you don't have to use them. Development environments such as Code, Blocks, and Microsoft Visual C++ make it possible to create great applications without ever touching a Makefile. Okay? So, for all intents and purposes, I have finished reading the entirety of C++ On For Dummies. I know I only started live streaming my read through as of page 288 at building with UML and the rational unified process, but I am very interested. So effectively, this is where I start the live stream here when I started back in October. But for all intents and purposes, I'm going to just call it. Put a fork in it, let's say, for this read through of C++ On For Dummies. Again, for anyone who's interested, this has been a read through live stream series, doing a read through of the majority of this book. This is C++ All-In-One For Dummies, 3rd edition, written by John Paul Mueller and Jeff Cogswell. And yeah, that's gonna do it. I look forward to doing more read-throughs in the future, but it would be nice to go ahead and get some coding in, get a little more practical time. I definitely haven't coded for over a year now, so I'm actually looking forward to doing that. And also, I need to return this to the library. That'd be good to do. All right, I'm gonna go ahead and do that. I'm gonna go ahead and close out the stream so I could go ahead and take care of that and then come back and still have to eat something for lunch, so that part. What time is it? Oh yeah, I'm gonna go eat something for lunch, drop this off at the library. Actually, the way the time is, I think I'll just go ahead and do the library. I'll get a little snack and then go to the library because I don't like dealing with traffic, especially on days I shouldn't have to deal with traffic. So I'm gonna go. Thank you so much for checking out this live stream. Thank you, Nicole, and thank you, Reinardina. And looking forward to starting some coding real soon. But next step is definitely setting up a virtual machine and getting link mint. And I kind of feel like not doing that today, though. I feel like waiting on that until a future day sometime this week or weekend and going from there. Because I'd rather, when I get back, focus on doing other things, like Monday mood control. Gotta do that. And then also maybe just some more Kingdom Hearts time. I would like to do some more Kingdom Hearts time. Hey, Renardina. Are you just putting random emojis, or does this have a meaning? I don't know if that's a bird, a duck, or a chicken. Blue, orange, underscore QCE. Alice, are you using C++ for game creation, or do you have a specific project you're working on? Oh, technically, no and no. So I did use C++ for a few projects while I was in grad school, but then I graduated, and so I haven't done anything with coding since I graduated last year. But I'm looking forward to starting soon, and I do have some things in mind. Specifically, I would like to, main project I would like to do is something that I can use to get my videos, some of my videos from this Becky828, and do some kinds of alterations that I need to do. And maybe even log some information. I'm still trying to decide on that one. I have to do everything on a very, very shoestring budget. So, still trying to figure out how to do things the most cost-effective route as possible. And then put the altered videos on a different channel. Yeah, right. Anyway, different account. And maybe that will grow a little faster without having to worry about copyright issues. Brian said, if I said that, I think I was trolling myself. Yes, I'm taking this to the library. I'm leaving it at the library. We're all done with, let's just see if I continue on with C++ on for Dummies. It's not, we're putting a pin on this. It's going to be a total thing in the future as I feel as time allows. But this particular book I am leaving at the library, which I'm going to go do now because I don't like traffic. So, yay! Thanks so much to anyone who I may have missed. Thank you, Blue Orange underscore QCE. Thank you to anyone who might check this out in the future. Stranger things have happened. And whenever, wherever, however, whatever, just make the most of it. That's the most important part. Bye-bye.